Good morning, good afternoon, or good evening, depending on where you're joining us from today. My name is Joseph Beringhouse. I'm the VP of Marketing here at Tamnoon. What that means is I'm going to be the MC today. We'll try and get through some questions at the end, save some time to even answer questions in the chat. If you haven't gotten a chance to review the report that we're going to walk through today, it's called the 2025 State of Cloud Remediation. It's all about cloud threats, cloud risk in your environment, and what we've analyzed to be able to get here today. I'm joined by Michael St. Onge, our head of technical services, that's going to walk you through his experience in the trenches going through some of what you see live today. And why I love these reports, I think they give you a really deep dive into benchmark data for you to look at against your own environment. Maybe you're way better than what we're going to show today. Maybe you're worse. Maybe you don't know. Wherever you are on that journey, I think it's something that we get to explore together, and you now have some data to look at to compare yourself to. Now, Tamnoon, very briefly, managed cloud security service that sits on top of whatever your favorite CNAP is. It doesn't matter what it is, how long you've had it. We sit on top of it, ingest all of your alerts, prioritize, and then help you triage and remediate all of those pesky alerts. So we like to say, stop thinking about the alerts and just leave it to us. And that's where Michael's team and his team comes in. Once again, I'm the VP of Marketing at Tamnoon. I'm joined by Michael St. Onge, the head of technical services here at Tamnoon, who actually recently went and built the AWS professional services team, as well as working in the DoD and other industries, as well as an actual security practitioner on the end user side before taking on that consultancy side, including owning his own consultancy as well. Now he helps our customers get control of their CNAP and all the alerts, and has firsthand experience that we'll talk through today. So we're going to go through the research methodology very briefly, and then we'll talk through the first three key findings in this report. And key findings 4 and 5 you can find in the recording in the chat of this session as well. So keep an eye out for there. Really important before we dive into the methodology, there are two components of this. We're looking at alerts from the last 12 months of data. That includes two components: open alerts, so every alert that is still currently open today, and then closed alerts during that period. And so there's things that are still open today. There's things that were closed at the very beginning of it. There's things that were closed at the end. But there's two data sets. And then within those data sets as well, we looked at as many alerts as possible, all of the 4.7 million alerts, which we'll talk about in a second. And then kind of a real point of view of those alerts, which leads us into the second point here. We combined those 4.76 million alerts and brought them into about ballpark 1,800 categories. They're classified ever so slightly differently in different categories. There's hundreds, if not thousands, of certain alerts that are the exact same thing because they've been triggered multiple times in different environments for whatever reason. And every CNAP labels it ever so slightly. Like the word has changed or it's in a different order. And so we used, yes, everyone's favorite word, AI, and our own AI engine within our product to be able to bring those together into a certain categorization. I think it's important to call out that everything we're going to talk about here is also before Tamnoon did any remediation. We are very good at remediation. It's Michael's literally entire job plus our own solution. So we're very good at remediation. What we're going to talk about is before Tamnoon touched it or did any of that. So again, 4.76 million alerts collected from 7 different CNAPs across 1,800 different categories. And we've got different data sets. If you really want to dive into the methodology, you can read that in the report. But for time's sake, I'm going to keep us moving along here. The analysis methodology that we're going to talk through today, just to make sure we're all using the same terminology, is this. A notification generated by your CNAP or CSPM is an alert. That's what we talk about in this report. That's what we're going to talk about in this data. There's 1,000 different alert types in all sorts of CNAPs. A notification generated by your CNAP, issue, finding, alert, scary thing, whatever, is an alert. Misconfiguration, there's 1,000 different ways that vendors love to talk about this, and so we just wanted to make it very clear how we talk about it. Vulnerability, IAM problem, misconfiguration, whatever it may be, all misconfiguration. We're using that term exclusively across this entire report. And with that, we're going to dive into the actual findings. This first finding I know is one of my favorites. And it's one of Michael's too, and we're going to dive into it in just a moment. But different CNAPs classify the same misconfiguration differently. This could be for a number of reasons, one of which we'll dive into in a moment. But different misconfigurations should not necessarily be informational versus high. Maybe they should. Maybe they shouldn't. Michael, what do you see in the wild?
Well, there's a couple of interesting reasons why we see this. First and foremost, the variation in severity levels actually reflects research and context that the CNAPs are trying to bring in to help us understand how important is this particular misconfiguration in the environment where it exists. So for example, we don't really see CNAP saying security groups should not allow unrestricted access to ports with high risk as being informational to critical. But what it is doing is it's looking at, is this a development environment? Is this a sandbox? Is this production? And they're trying to demonstrate that the production environment carries a higher severity than the non-production environment, for example. It's interesting and super helpful, assuming it's correct. There's a couple ways in which this goes wrong. The first is it is subject to the garbage in, garbage out principle. Stop me if you've heard this before, but sometimes you get customers who label their production environment as non-prod and their non-production environment is production. If that happens, the CNAP doesn't know that, and so you're likely to see severity levels that don't reflect reality. The second way in which this can go wrong is when you have a non-production environment that has access to production data or production resources. In that instance, the CNAP again is doing its best to try to tell you this is less important, when in fact to the threat actor and to the overall risk, it doesn't matter, right? Compromising a non-production resource that gets you to production data, I would argue that still should be categorized at the highest severity level. So I think that's why we see this variation. It's not as surprising as it might seem.
I do think it's critical that we talked about this a lot, that difference as well. If your current security tooling isn't set up to take that configuration adjustment in place, you either need to configure it properly or be prepared to spend a lot of time triaging. And I think that's something that we do quite a bit, is also configuring those cloud security tools, whatever the CNAP is. Maybe it's a cloud native tool because you're not at a paid tool yet. Maybe it's an open source tool, whatever. If you're not able to configure that solution to fit your environment and fit your needs, it's going to be so hard to get out of that backlog, and your team is just going to spend cycles doing that.
Absolutely. Tuning your CNAP is so important, and that's exactly what we're talking about here, is making sure that the rules reflect the reality of your risk appetite, the reality of your environment, and they're bringing in as much context as they can to help you make these triage decisions and prioritization decisions as quickly as possible.
So let's look at a real scenario. And Michael, let's talk through this one a good bit. So if you have two CNAPs, maybe it's the exact same CNAP in the scenario, maybe it's different. What should the engineer do? You have CNAP A that flags something as a high risk due to open internet access. That's it. CNAP A says high risk. CNAP B says it's a medium risk. The bucket is not sensitive and does not contain any PII. It's got some picture for your website. Cool. What do you do? What's the difference?
It's interesting. It potentially helps me triage this particular alert. If I know that it doesn't contain sensitive data and I believe it, those are two different statements, and I know it doesn't contain anything, it contains information that we're expecting to publicly go out the door, then absolutely, the remediation path here is making sure this meets the correct architecture. And if it does, we're probably going to configure the exclusion in our CNAP and just reduce the noise. The trouble can be, if the data isn't meant to go out the door publicly, even if it's non-sensitive, doesn't mean everyone should have it, then it can be a bit misleading. And sometimes we might see these risks buried as mediums when in fact they do represent a very real risk to the business.
Without a doubt. Context matters, y'all. Make sure you're bringing context into both the way you're triaging, prioritizing, and even within your environment. I love that you even called out, if it is something that we don't necessarily care about or need to care about and it's purposeful, go back and reconfigure your rules properly. I feel like a lot of people just like, no big deal, move on. But you're creating cyber trash, litter, whatever you want to call it. And it's just like, it's just there for somebody else to pick up and deal with and not fix today. Super critical part of this whole thing. It's a full process, not a partial process. All right, let's dive into takeaway 2. 10 plus years into cloud security, we're still wildly exposed. I think the chart kind of speaks for itself. Severity really does matter in the time that it takes to close an alert. Our hypothesis to some extent too, as we were going through this report, low and information will get closed just by getting rid of junk in your cloud. You're cleaning something up, probably shouldn't have been there anyway. It just kind of goes away. It wasn't necessarily a purposeful choice. So we kind of ignore those in the scenario, but critical versus medium versus high. Michael, let's talk about this for a second. What does your mind go to right away as you see critical versus medium and even that time scale?
Yeah, there's a couple interesting things at play here. First of all, the low informational, sometimes even medium alerts, these tend to be very simple misconfigurations. I'm going to flip a bit from 0 to 1. It likely has minimal operational impact to my application or my workload. And so these are easy changes to make. They don't require a whole lot of stakeholder coordination. They don't require a whole lot of planning. Simply stated, the change control process is pretty easy here. When you start to get into highs and criticals, you're dealing likely with more complex issues, permissions, networking, and you're dealing with potentially issues that reach a complexity where you're bringing in multiple stakeholders. Now I have to get the networking team, I have to get the identity team, I have to get the application owner, maybe I need someone representing the user of this application so that we can understand how best to unpack this, what the right remediation path is. And so I'm a little surprised, maybe at the distribution, but not at all surprised that it's easier to fix easier problems than it is to fix hard problems.
Yeah. Very much so. And let's dive into maybe the really hard problems. Let's look at just critical alerts. Critical alerts, we said a second ago, take 128 days to solve on average, which is scary in and of itself. And also, again, use your own benchmark data here. Are you better? Are you worse? That's the average. Do your own kind of math. If you don't know, benchmark yourself. Go look and see if you can figure that information out. If not, call us. We can help too. But Michael, let's analyze that process here for a second. What do you think is the hardest part about each stage, maybe, and like why?
As we look at this whole thing, the thing that really jumps out at me is we're not getting these alerts back to the person who can fix it fast enough. Too often we run these CNAPs, we create reports, security team distributes that through their leadership. It goes up 3 levels of management, comes back across at some point, and then it comes back down. And it just takes forever before we're finally getting this alert into the hands of someone who either created the misconfiguration or knows how to fix the misconfiguration. And so that's the first big thing that jumps out at me. The second big thing is 21 days to engage. That is a long time. That is a long time where no one is doing anything. It just sits in the queue, and it's likely because you're backed up fixing other things, and it's difficult to triage these things at scale on your own. The 42 days to triage and impact analysis, it's gathering that context, right? Everyone likes to talk about automated remediation, like everything is just flipping that bit from 0 to 1, but it's rarely that simple. And it does take time to understand the context. What happens if I change this thing? Go inspect the logs, for example, which is part of our playbooks. Usually, let's make sure before we prevent a particular behavior from occurring in the future, let's make sure we're not breaking anything that exists today. And then the approvals and remediation, I mean, this is just simply working through the change control process. And of course, the larger, more regulated the organization and the workload, the longer these things take. Again, that's more stakeholders equals more time. It's hard to accelerate the humans.
And Michael, that assumes that the person or thing is still running and or working there, not to mention, right? What if that person left?
Yeah, we definitely see that in the wild where, things were developed a long time ago and the person who built it has long since left the company and now falls into what we call legacy.
Yeah.
Congratulations. We've kept the lights on and it's still running, but no one understands how it works and everyone's scared to change it.
Yeah. Man, I feel like that's the biggest part. We're scared to change because we don't know what could happen if that thing doesn't work right. What will break. It's a big part of why those criticals, I think, sit too. And that takes us here to takeaway 3. I think it was one of the more interesting things for me was seeing just the vast disparity between criticals and highs. Our critical alerts making up 1.4% of the total CNAP alerts, highs making 33.7, and then of course about flat the rest of the way, which is also a little surprising. Michael, first gut reaction here. Tell me what your thoughts are.
I'm not too surprised. I think our CNAP vendors know that if everything's a priority, nothing's a priority, right? So if they label everything critical, it's very difficult to sift through all that stuff. And so they're doing their best to say anything we label as critical out of the box, mind you, we believe that these are the most important things for you to solve. It brings us back to the point earlier, you should be tuning your CNAP. You should decide whether those are the things that are critical to you. And if they're not, or there's other things that are, make sure you're pulling those things in and configuring them as critical. And so because they do that, what happens is things that are genuinely very risky, they end up in that high bucket, right? We can't call it critical because everything can't be critical. And so we'll just make everything high instead. This is where the 5 severity levels, I think, do the security industry a disservice. One of the earliest conversations we had here at Tamnoon was not about changing the severity level. Well, it was about changing the severity levels and should we get into that game? And the decision was no. There's no value in doing it. Instead, we should be talking about prioritization. And so that's exactly what we do is we rack and stack these things by prioritization. But what that means is there are some very interesting things hiding in those high vulnerabilities. So super quick for those that aren't familiar with the AWS Instance Metadata Service, it's a service that runs on your EC2 instances. It allows you to make a web call and retrieve a bunch of information about the running EC2, including the credentials that EC2 instance would use to make AWS calls on your behalf. Earlier 2018 timeframe, there was a very famous attack. I won't bring it up. But it leveraged the instance metadata service version 1 in a server-side request forgery attack, where an attacker was able to use an SSRF, trick the EC2 instance into making that web call, retrieving those credentials, and then unfortunately those credentials were very overprivileged, and the threat actor was able to make off with some data as a result. What is kind of interesting is sure it's a high. I think it's this is a very valid vulnerability. We're still seeing this in the wild today. But what's more interesting is there's an entire attack path that I just laid out there, right? The threat actor has to find that public instance. The instance has to have an application that has a vulnerability that enables an SSRF attack. The EC2 instance has to be running the instance or allow calls to the instance metadata service version 1, which is the unauthenticated version. And then the credentials have to be interesting. There has to be credentials and they have to be interesting. If we shift to the example on the right, the publicly exposed bucket, there is no attack path. You have put your data on the internet for absolutely anyone to go grab, and someone will absolutely go grab it. And so this is another one that can end up in that high bucket, pun intended, because we can't categorize everything as critical, as we just talked about. And oftentimes, these S3 buckets were made public intentionally. These days we could argue there's some better architectures that you could put together than directly exposing the data, but regardless, if you see this type of misconfiguration or alert in your environment, it's definitely worth looking into because again, there is no attack path. All the threat actor has to do is know it exists and your data is out the door.
Let's talk about just some real world implications of that data we just looked at. I think this is an important one, and it's not meant to be in your face or anything, but if we acknowledge the hard truth a little bit as well, that if your criticals are 1.7% or 1.4% of your alerts and 33% of your alerts are highs, if you're not doing something to make it to where things that are highs that really aren't important go maybe into medium and things that are really crazy come into criticals, if you're not able to do a little bit better prioritization than even that massive chart, you're going to be in your highs for a long, long time. And so there needs to be a way to bring things out of those highs like we just talked about, that get to the surface and even get to the right person, going back to Michael's other point, to be able to get out of that backlog. It's something we're quite proud of, actually, that we do get a lot of our customers out of their backlogs, certainly out of their criticals within a very, very short period of time, and then even break into highs. And I know even in some scenarios we're into mediums now, Michael, which is even more insane. You got to have a good process for that.
Go back to that attack path. If that critical is going to take 5 stakeholders and 3 months to fix, but there's a medium or a low that'll take me a week, I'm going to prioritize that medium or that low for this customer so that we can disrupt that attack path while we work on these critical issues that are going to take longer.
With that being said, key takeaways here, Michael. Why don't you take this one?
Sure. So, do understand different CNAPs are going to classify misconfigurations differently. Make sure that the alerts and severities are configured the way that is interesting to you. Meaning, if you're getting a critical from your CNAP and you look at it and every time it rolls in, you don't think it's critical, change it. It's best advice I can give. We are still widely exposed. It is really hard. There's no magic bullet. It's hard work to pour through these things. We have AI and automation and all these other tools at our fingertips, but it's hard work. That is genuinely where it is. Again, tune your CNAP, focus on the things that matter the most to the business. I'd rather see someone have 10 criticals open, but their risk profile, their threat exposure is reduced than someone who's part of the zero criticals club and still gets popped because there's one S3 bucket labeled as a high and all their data went out the door.
Awesome. Thank you, everyone, for joining us today. Thanks, Michael, for your time. If anyone has questions or wants to talk with Michael, hit him up on LinkedIn. I'm sure he'd love to chat about cloud and security. And if you have any questions for us at all, reach out to us, tamnoon.io. We're always happy to help. We do this every single day with our customers. And so happy to help anyone wherever they are on their journey. Thanks so much for joining us today.